Hello and welcome to section 3.5, Implicit Differentiation. In this section, we look at this technique for implicit functions as opposed to explicit functions. Up until now, we've been dealing with explicit functions, where one variable, y, for example, is written explicitly as a function of x. Okay, and that's possible in a lot of cases. But sometimes we cannot write y in terms of x. Like for example, in a function like this one here. Right, we have a function. It's written with both x's and y's in its equation. And so now it'll be hard to isolate the y. Okay, and so as we look at a function like this, how do we get the derivative for this function? Okay, so we end up using what we call implicit differentiation. Now, the way implicit differentiation works, if your variable in the expression agrees with what you're taking the derivative with respect to, like let's say we usually take the derivative with respect to x, right? And your equation only has x's in it, you do your regular rules for differentiation. Okay, so here this would be for x cubed, we use the power rule, right? Now, what if we had the derivative with respect to x, but now the variables disagree? So we have an equation with just y's, y cubed. Okay, so we take the derivative with the power rule, but then we have to add on to it the chain rule. Okay, so when the variables agree, you use your simple derivative rule for that expression. If there are variables that disagree with respect to your derivative variable, then you have to incorporate the chain rule as well. Okay, so something like y cubed, we take the derivative 3y squared, and then we take the derivative of y with respect to x. Okay, and you multiply the two together. Okay, for something like c, you have a combination of x's and y's. So for the x one, you take the regular derivative of x is 1, and then for the 3y, take the derivative of 3y, which is 3, and then you multiply by dy dx. Okay, so you're using the chain rule. Okay, for x times y squared, that would be a product rule. So the rule is, it'll be x times derivative of the y squared. So we would get x times 2y. And then as we do 2y, we do dy dx. Plus y squared times derivative of x. Y squared times derivative of x is 1. And so we end up with 2xy dy dx plus y squared. Okay, let's do a similar problem to that so we get to see it worked out live. So let's say we have derivative with respect to x of x cubed times y to the 4th. Okay, so it's a product rule, so we do x cubed times the derivative of y to the 4th. Okay, derivative of y to the 4th would be 4y cubed, and then remember to multiply by dy dx, plus y to the 4th times derivative of x cubed, which will be 3x squared. Okay, clean it up a little bit. Any coefficients you'll bring to the front. You'll keep it in alphabetical order. Okay, so we have 4 here will come in front, x cubed, y cubed, dy dx, plus the 3 would come to the front, 3, x squared would come to the front, y to the 4th. Okay, now normally we wouldn't stop there, we want to solve for dy dx, but for now, for this problem, we're just showing the process of the implicit differentiation. Okay. Okay, so if we're taking the derivative of an equation, okay, and not just an expression, and we're trying to get dy dx, then we would solve for it. Okay, so the rules are pretty straightforward. We differentiate both sides of the equation with respect to x, and then we collect all terms involving dy dx to the left side of the equation, and all other terms will move to the right side of the equation. Factor out dy dx on the left side, and then solve for dy dx. Okay, so let me show you guys how this works. Okay, so we have, if we're looking at this equation, start off with taking the derivative of each term. Okay, so derivative of y cubed would be 3y squared times dy dx, this is a y term. Derivative of y squared would be 2y dy dx minus derivative of 5y would be 5 times dy dx minus derivative of x squared is 2x equals derivative of a constant is 0. Okay, so notice we have a lot of dy dx terms on the left. What I'll do is I'll move the 2x term to the other side. Okay, so plus 2x plus 2x. And so you could factor out a dy dx from the left. Okay, so if we factor out the dy dx from the left, you have 3y squared plus 2y minus 5 equals 2x. Okay, and then divide both sides by 3y squared plus 2y minus 5. Okay, so that you have the dy dx alone. Okay, so dy dx will be alone equals 2x over 3y squared plus 2y minus 5. Okay, and that would be the equation for your derivative. Okay, graphs and differentiable functions. So this question says, if possible, represent y as a differentiable function of x. Okay, so for a, x squared plus y squared equals 0. This looks like it's in the form of an equation of a circle. However, we notice for equation of a circle, we usually have x squared plus y squared equals the radius squared, right? And our radius here looks like 0. So if we look at the graph here on the right, right, if it's a radius of 0, that means all we have is a little dot. Okay, so if it's a dot, we're not going to be able to differentiate that dot. We're not going to be able to get a slope to represent, you know, a derivative to represent the slope for that dot. So this will not have a differentiable function of x. Okay, let's take a look at B. B is a circle, full-fledged circle, right? X squared plus y squared equals 1. You see it here. Okay, it's a radius of 1. Okay, center is at 0, 0. And we can solve it for y as a function of x. Right, so very simple to do. We just subtract x squared. So we subtract x squared and we get y squared equals 1 minus x squared. Then we take the square root of both sides to get the y alone. So we get y equals plus or minus the square root of 1 minus x squared. Okay, so the plus version, the positive version, will be the top half of the circle, and the minus version will be the bottom half of the circle. Okay, let's take a look at part C. Part C, the graph would be this sideways parabola opening up towards the left. Okay, and so that we could easily write as a differentiable function of x. We could solve it for y. So subtract x, both sides. So we have y squared equals 1 minus x. Again, take the square root. So we have y equals plus or minus the square root of 1 minus x. Okay, so similar idea. The positive version with the plus in front will be the top half of the parabola. The minus version will be the bottom half of the parabola. Okay. Okay, and so we're trying to show that if we could write the equation as y in terms of x, then we could do a simple derivative, explicitly, like the old way. Now the problem occurs when we get the equations to look like what we had up here with the y cubed plus the y squared minus 5y minus x squared. Right, so anything like this, it will be very difficult to express as y equals in terms of x. Okay, so then we have to use our implicit differentiation, which we did, using the chain rule to come up with an equation for the derivative. Okay, so let's take a look at our next section. It says find the slope of a graph implicitly. Okay, so let's do that. They give us the equation for the graph. Okay, so let's take the derivative of it to get our tangent, slope of the tangent line formula. So derivative of x squared would be 2x plus derivative of 4y squared, power rule, 2 times 4, that's 8y, and then dy dx. Okay, so remember, anytime you take the derivative of a non-x term, you're going to end up multiplying by dy dx at the end of it. Okay, and then here, this is just a constant. Derivative of the constant, you guys know, is 0. Okay, so now solve this for dy dx. So first thing we would do is minus 2x, both sides. So if we do that, we have 8y dy dx equals negative 2x. Okay, divide by 8y. So we have dy dx equal to, you could reduce between the 2 and the 8, divide by 2, so we have negative x over 4y. Okay, and then the slope of the tangent line, so they want you to figure out the slope, only the slope, and they give you the pair of xy values. Just plug it in now. Okay, so let's plug it in. So negative x, so we have square root 2 for the x, and a negative 1 over square root 2 for the y. Okay, so negative, that would be square root 2 over, and then it would be 4 times y, so the y is negative 1 over square root 2. Okay, so what does that give us? So if we have this, this would be negative square root 2 over 4 times negative 1, that would be negative 4 over square root 2. So now remember, as we divide by a fraction, we can multiply by its reciprocal. So we have negative square root 2 times, multiply by the reciprocal, square root 2 over negative 4. Now, square root 2 times square root 2 would be 2. You can cancel out the negatives now. You have negative on top, negative on the bottom. You would still have the 4. And then finally reduce your fraction, so you end up with 1/2. Okay. Let's take a look at our next one. Finding the slope of a graph implicitly. Okay, so here we have our equation. 3 times x squared plus y squared, that quantity squared, equals 100xy. And we want to find the slope at the point 3, 1. Okay, so what I will do, I'm going to put this on a new page just so we have plenty of room. Okay, so for this problem, again, we want to take the derivative implicitly. Okay, so let's do the derivative of both sides. Okay, for the left side, we could do a general power rule with the outside. So there'll be a chain rule involved in here. Okay, so 2 times 3 times x squared plus y squared. Reduce the power on the x squared plus y squared, so there's a 1. Times the derivative of the base, so the derivative of x squared is 2x, plus derivative of y squared is 2y. But just remember, for the 2y, you have to multiply by dy dx. Okay, for the left, so that's for the left side. Now on the right side, as we take the derivative, we could do 100 x times derivative of y, so 100x times dy dx plus y times the derivative of 100x, which is 100. Okay, so next up we have here 6. We can make this 6 x squared plus y squared times 2x plus 2y times dy dx equals 100x dy dx plus 100y. Now what we want to do next is we'll take this quantity and we'll distribute it into our, like as a group. This would go and multiply with the 2x, and then it would multiply with the 2y dy dx. Okay, so we would have 6x squared plus y squared times 2x plus 6x squared plus y squared times 2y dy dx equals 100x dy dx plus 100y. Okay, we're going to simplify slightly and then we'll move some terms around. Okay, so the 2x will come to the front and multiply with the 6, so this will be 12x, x squared plus y squared, plus the 2y would come to the front and multiply with the 6. And so that would be 12y, x squared plus y squared times dy dx plus 100y. Okay, so now anything without a dy dx we're going to move to the right. Anything with a dy dx will move to the left if it's not there already. Okay, so for example, this term will move to the right. Okay, because that doesn't have the dy dx, and then this term with the 100x dy dx, we'll move that to the left by subtracting that. Okay, so what does that result in? So that means we have this cancels, and then just remember to write this minus 12x x squared plus y squared on the right, and then this cancels from here. That'll reappear on the left. Okay, so we got 12y x squared plus y squared dy dx. The minus 100x will join it, so minus 100x dy dx equals, we're left with the 100y, and then the minus 12x, that'll join it on the right, x squared plus y squared. Okay, and as we mentioned earlier, so we have all the dy dx terms. Factor the dy dx out. Okay, so if we pull it out, we're left with 12y x squared plus y squared minus 100x equals 100y minus 12x x squared plus y squared. Okay, and then what we'll do to both sides is we can divide by 12y x squared plus y squared minus 100x, And then same thing here, divide by 12y x squared plus y squared minus 100x. Okay, so we end up with just dy dx equals 100y minus 12x x squared plus y squared all over 12y x squared plus y squared minus 100x. Okay, now for that question we wanted to figure out the slope at the point 3, 1. Okay, so slope at 3, 1. Okay, so now the rest, we just plug in 3 for the x and 1 for the y, evaluate it, and then we'll be done. Okay, and that'll give us the slope. This is our dy dx, which is our slope anyway. Okay, so now just plug in, we have 100 times 1 minus 12 times 3 times 3 squared plus 1 squared all over 12 times 1 times 3 squared plus 1 squared minus 100 times 3. Okay, and now we just simplify PEMDAS rules, obviously. So you could start with inside the parentheses, then we tackle the exponents. Let's take a look. 3 squared is 9, plus 1 squared is 1, so 9 plus 1 is 10. We have 100 times 1, which is 100, minus 12 times 3, that's 36, times 10, over 12 times 3 squared plus 1 squared, so that's another 10, minus 300, right? 100 times 3. Okay, so that gives us 100 minus 36 times 10 is 360. 12 times 10 is 120, minus 300. 100 minus 360 would be negative 260. 120 minus 300, that would be a negative 180. Okay, we can chop off our zeros, reduce, we could divide by 2, right, top and bottom, cross out the double negatives. So if we divide by 2, we have 13 for the top, divide by 2 on the bottom, we have 9. Okay, so that means our slope at 3, 1 for this curve would be 13/9. And that would be our final answer for that one. Okay, and this was the curve for it. So at 3, 1, we have a slope of 13/9. Okay, and it kind of makes sense. It's a positive slope, right? Slightly more steep than a slope of 1. Not as steep as a slope of 2. Let's take a look at example 6. Find dy dx implicitly for the equation sine of y equals x. Then find the largest interval of the form negative a less than y less than a, on which y is a differentiable function of x. Okay, so if we try to take the derivative of sine of y equals x. Derivative of the sine is the cosine, so we have cosine of y times dy dx, and then derivative of x is 1. Okay, and then to get dy dx alone, we can just divide by cosine of y, divide by cosine of y, so we end up with dy dx equal to 1 over cosine of y. Okay, and then the largest interval about the origin for which y is a differentiable function of x is, well, we note that if you're looking at the graph, okay, for it to be the largest interval. Now notice when we get to these edges, we get the derivative to be undefined. Okay, so as we go from if you want to do like vertex to vertex, but if you go from this point to this point, this would be the largest differentiable, right? You could do the same thing for, like, if you went from here to here. You just want to pick one of them because they're all going to be the same length. Okay, the slope at those points are undefined. Okay, so that means the derivative does not exist, right, at those points. Okay, so for this, if we're looking at our y values, which is what they were telling us in the problem, that would be the largest interval. Negative pi over 2 less than y, which is less than pi over 2. Okay. And that was our work for the other problem. Okay, finding the second derivative implicitly. Okay, so for this one, let's take a look at this one on a separate page. So we could take derivatives repeatedly, just like with explicit functions. We could take higher order derivatives just again and again and again. Same thing we could do with implicit differentiation. Okay, so here we want to take the second derivative. Okay, so take the derivative, both sides. We would have 2x plus 2y times dy dx equals derivative of 25 is 0. Okay, again, solve for dy dx, so subtract 2x both sides. 2y times dy dx equals negative 2x. Divide by 2y. Divide by 2y. So we get dy dx equals, now here we can cancel out the 2's, so we're left with negative x over y. Okay, and now let's take the derivative of dy dx. Right, so take the derivative of negative x over y. Okay, so this would be to get our d squared y over dx squared. So this would be quotient rule. So with the quotient rule we have y times the derivative of negative x, so that would be y times negative 1 minus negative x times the derivative of y. Now derivative of y is 1 times dy dx. All over the denominator squared. So y squared. Okay, so does that simplify at all? We have y times negative 1 is negative y. And then here we have a minus of a negative product, so that's going to be plus x times dy dx all over y squared. Okay, now important step coming up right here. In your problem you have a dy dx right here. And you solved for dy dx earlier and you got this. Right? This is your dy dx, negative x over y. So guess what? You will replace dy dx with negative x over y. Okay, so let's do that. So we have negative y plus x times negative x over y over y squared. Now this obviously doesn't look very nice with our fraction, with a fraction, so we have to simplify this. Okay, don't ever leave it like this. This is not acceptable in math circles. Okay, so how do we simplify it? Let's see. Well, we have here for negative y plus, this will be, well, it's a negative times positive, so let's make that minus x squared over y cubed. Okay, so to get rid of this y denominator that's in my numerator, what I could do then is multiply top and bottom. I don't know why I made that y cubed, but that should be y squared. We were going to multiply top and bottom by y. Oh, I see. I was going a step ahead. If we multiply top and bottom by y, that'll still keep everything in check, right? In balance. Whatever we multiply the top, we multiply the bottom. Okay, so if I distribute my y on the top, I have negative y squared minus, now my y and my y here would cancel. That's the reason why I just did the whole y over y thing. And my denominator becomes y cubed. Okay, and then we have another extra little trick at the end. Notice we have a negative y squared minus y squared. I could pull out my negative and look what happens. If I pull out my negative, I have y squared plus x squared all over y cubed. Okay, now where did you see y squared and x squared in the problem? You saw it in the very beginning, right? X squared plus y squared equals 25. Okay, so what we're going to do then, replace your x squared plus y squared, right? Because you know x squared plus y squared equals 25. Okay, you're going to swap this out, right? X squared plus y squared equals 25. So that's going to go, 25 will go in the place of x squared plus y squared. Okay, so your final answer for the second derivative is negative 25 over y cubed. Okay, and that would be the final answer. Questions? Well, if you have any questions, just email me and I'll get back to you. Okay, skip. Okay, finding a tangent line to a graph. So let's find the tangent line to the graph of x squared times x squared plus y squared equals y squared at the point radical 2 over 2 comma radical 2 over 2 as shown in the figure. Okay. Okay, so let's take a look. Let's find the derivative then of both sides. To help us a little bit, let's do this. Let's distribute our x squared and we will write everything on one side. So we have x squared times x squared is x to the fourth plus x squared times y squared. And then let's bring the y squared to the left, so minus the y squared equals 0. Okay, and now let's take the derivative. So we have 4x cubed plus product rule here. So x squared times 2y times dy dx plus y squared times 2x minus 2y times dy dx equals 0. Okay, so let's keep the terms with the dy dx together. Okay, so that'll be, we have x squared times 2y times dy dx, x squared times 2y times dy dx minus 2y times dy dx, and then all the other terms let's move to the other side. So the 4x cubed, okay, we'll bring to the other side, would make it a minus 4x cubed. And then here this will be a 2xy squared. Let's move that to the other side, so minus 2xy squared. Okay, so factor out the dy dx. We have dy dx, x squared times 2y, that's 2x squared y. 2x squared y minus 2y equals negative 4x cubed minus 2xy squared. Okay, divide both sides by 2x squared y minus 2y. So we have dy dx equals negative 4x cubed minus 2xy squared over 2xy x squared y minus 2y. Okay, so Next we have to figure out the slope at the point. And the point is square root 2 over 2 times square root 2 over 2. Now what might help you plug this in a little easier is if you could factor out as much as possible some common factors. You just rewrite this in, let's say, if we factor out on the top, we factor out a 2. In fact, there's a lot of minuses. We could do this. We could factor out a negative 2x on top. And then so we're left with 2x squared plus y squared. And then for the bottom, we have a 2y and a 2y. And okay, let's factor out a negative 2y. So if that happens, we have negative x squared plus 1. Okay, so that's going to help us a little bit, because look what you could do now. The negative over negative you could cancel the 2's. So you have x over y, 2x squared plus y squared over, and let's do this 1 minus x squared. Okay, and now we could plug in our x and our y. Okay, so we have square root 2 over 2 times 2 square root 2 over 2 squared plus square root 2 over 2 squared over square root 2 over 2 times 1 minus square root 2 over 2 squared. Okay, so let's simplify it then. Now these two, square root 2 over 2, you could cancel those, right? They're factors. And then let's focus on the inside. So we have on top 2, and then square root 2 times square root 2 is 2, and your denominator 2 squared is 4, plus, same thing there, 2 over 4, and then the bottom 1 minus, same thing there, that would be 2 over 4. Okay, so 2 over 4 is 1/2. 2 times 1/2 is 1. We have 1 plus 1/2 over 1 minus 1/2 is 1/2. So we have 3 halves over 1/2. Right? If we make the 1 equal 2 halves, that becomes 3 halves over 1/2, which will just be 3. Okay, so that's our slope. And then they wanted the equation of the tangent line. Okay, so we have square root 2 over 2, square root 2 over 2. This will be like our x1 and our y1, and we have a slope of 3. So y minus square root 2 over 2 equals 3x minus square root 2 over 2. Okay, so we have y minus square root 2 over 2 equals 3x minus 3 square root 2 over 2. Right, we just distribute. And then we could add square root 2 over 2 to both sides. So we have y equals 3x. Now a negative 3 square root 2 over 2 plus 1 square root 2 over 2. That would just give us a negative 3 plus 1. That's a negative 2 square root 2 over 2. Cancel out your 2's. So you're left with y equals 3x minus square root 2. Okay, and that would be the final answer to that graph, to that equation. Get that one. Okay, logarithmic differentiation. Sometimes it's easier to use logarithms to help you differentiate. Right, so we could use logarithmic differentiation and the properties of logs, and that'll help us in terms of taking the derivative. Okay, so let's see how we would do this one. Okay, so when we take the derivative of this, what we will do is take the ln of both sides. Right, so we would have ln of y equals ln of x minus 2 squared over square root of x squared plus 1. Okay, so now we'd use the properties of logs to expand on this. Okay, so one of the things is, well, the left side would be ln of y. Now we haven't taken derivative yet, right? So it's just properties of logs. Okay, so this is going back to pre-calc. Okay, so now for our fraction, we would say this is ln of x minus 2 squared minus ln of square root of x squared plus 1. Okay, so that's what it would translate to in the beginning. And then we could take it a step further with our exponents. Exponent rule for logs. We could bring the 2 in front. This will be 2 times ln of x minus 2 minus. Now the square root of x squared plus 1 is x squared plus 1 to the 1/2. Okay, so that 1/2 will come in front. So 1/2 ln of x squared plus 1. Okay, now that you have it fully expanded out, now you could take the derivative. Okay, so you could take the derivative from here. So now if we do derivative of ln y, this would be 1 over y times dy dx equals derivative of 2 times ln of x minus 2 would be 2 times 1 over x minus 2 times the derivative of the base, which will just be 1, minus 1/2 derivative of ln x squared plus 1 would be 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x. Okay, simplified a little bit. Still have 1 over y dy dx equals 2 over x minus 2 minus, now here the 2 of the 1/2 with the 2 here would cancel, so we'll be left with the x on top over x squared plus 1. Okay, so now what we want to do is combine this fraction, but in order to do that we need a common denominator. Right? Our LCD would just be putting together the two denominators to give us our LCD. Right, so now this fraction, that means I have to multiply by x squared plus 1, top and bottom, and then the fraction on the right I multiply by x minus 2, top and bottom. Okay, so now let's simplify. So I distribute the 2, so 2x squared plus 2 minus, distribute the x, so x squared minus 2x now you have the same denominator, x minus 2 over x squared plus 1. Simplify this, you'll distribute the minus into the parentheses. Okay, so let's simplify that on the fly. 2x squared minus 1x squared is x squared. And then we have minus of a minus 2x, that's a plus 2x. And then we have a plus 2 over x minus 2 times x squared plus 1. 1 over y times dy dx. Okay, multiply both sides by y to get rid of the 1 over y. Okay, so that's gone. So we have dy dx equals, and now you want to replace what y is equal to. Right? In the beginning of the problem, we had y is equal to x minus 2 quantity squared over the square root of x plus 1. So we're going to replace y with that. Okay, so x squared plus 2x plus 2 over x minus 2 times x squared plus 1 times, again, replace y with x minus 2 squared over square root of x plus 1, x squared plus 1. Okay, so then what happens is we could actually simplify this a little bit. We have x minus 2 squared on top. We have an x minus 2 on the bottom. Let's cross out 1 from the bottom with 1 from the top, so I could cross out my exponent. Okay. Now, my denominator, I have x squared plus 1. And then here I have x squared plus 1 in the square root. So it's kind of like I have, they're the same base. Right? It's like I have a times a to the 1/2. Right, now if I a is to the 1, I could say this is a to the 2 over 2 times a to the 1 over 2, and just use my product rule and add them and get a to the 3 over 2. Okay, so that's what's going to happen here with these two. Okay, so we have x minus 2. I'll put that in the front here, x minus 2 times x squared plus 2x plus 2 over x squared plus 1 to the 3/2. And that will be the final answer for that one. Okay, and then let's take a look at this one. This will be another logarithmic differentiation. So we take ln of both sides. Ln of y would equal ln of x to the 2x. So doing that will allow us to write the 2x in front. Okay, and now that we have it written like that, we can take the derivative. Okay, so derivative of ln y would be 1 over y times dy dx. And then here, this would be a product rule. 2x times 1 over x plus ln x times 2. Okay, so the x and the x in the denominator, they would cancel. So I have 1 over y times dy dx equals 2 plus, and then bring the 2 in front, 2 ln x. Okay, and now I could multiply both sides by y, and then multiply this side by y. Okay, so I'm left with dy dx 2 plus 2 ln x, and I think you guys will know what will happen here. We replace the y with x to the 2x. Okay, you could leave it like that. Generally, if it's a single term like this, we'll bring that to the front. Okay, so we'll have x to the 2x times 2 plus 2 ln x. Okay, and that would be the end of that problem. Okay, if you have any questions, just reach out to me. Okay, any questions, reach out to me by email. Have a good day, have a good night. We'll see you soon.